Finally, in conclusion of our work is that the fault ED elastic dislocation methodology applied along a faulted rule-oriented line, applied different body condition and boundary element got the reasonable results. ED model include intra-reservoir faults in basal thrust result, display predictor stress field and the prospect showing fracture corridor characteristics. We have compared fault ED model fractures and characteristics with well bore FMI. The fault ED model predict that well 1 has more fracture density than well 2 and 3 and fractures are oriented almost in west-northwest, east-southeast or northwest-southeast direction. Image log of well 2 and 3 showing less fracture density and strike almost northwest-southeast while well 1 image log fracture density is high comparatively and striking north-northwest, south-southeast. The agreement between model and well-bore FMI result adds confidence in the use of fault ED methodology for fracture corridor identification. My recommendation on the basis of this study is that the drilling plan must be prepared after applying the ED methodology on a well-balanced 3D structure geological model, both for frontier and development area. The seismic interpretation must be validated, restored, and balanced first before applying ED methodology. The appropriate rock mechanical properties, laboratory standard, or actual values for carbonate reservoirs should be incorporated in ED modeling. The ED methodology must be exercised for the prediction of sub-seismic fault and fracture sets analysis, stress analysis, MEM, and failure state analysis. ED modeling must exercise because in compressional, extensional, and strike slip or transpressional tectonic zone, the sub-seismically identified fault and fracture set may or may not be in the same orientation strike as picked by the naked eye seismic scale and 2D, 3D seismic interpretation. Transverse faults and fracture system may also exist sub-seismically, which must be addressed during planning a well for fracture reservoirs. Acknowledgement, we are very grateful to DGPC for providing permission to utilize the data for research work. We are also thankful to the management of UGDCL for its support and guidance. And we are also thankful to its ATC technical committee who gave us an opportunity to present my work in front of you. These are some of the references which we have utilized during the study. And thank you.
Thank you, Imran. Very good presentation.
Thank you, sir. Thank you.
Now time for 1 or 2 questions. If anybody interested, please raise their hands. Anyone? Last call for anyone? Shahid, आगे आ जाओ.
Yes, yes, yes.
Stress orientation. I mean, what is the difference between the stress orientation of other 2 wells? First well, you have picked the same minimum stress direction through fracture, and other 2 well has different. Why it is different? It's basic question.
Actually, the stress orientation, when we look into the extensional tectonic regime, it is all the maximum stress is always perpendicular in that area. But when we look into the reverse or thrust faulted area, the maximum stress is oblique, always oblique or horizontal in that direction. So you can see that we are working in this complex compressional tectonic zone. So here is the maximum stress is just in horizontal or oblique direction, while the minimum stress is just perpendicular in that.
Thank you. Very good. Very nice paper. Thank you.
Thank you.
Thank you, Imran.
Thank you.